resolving the early versus late selection debate with fMRI. In this experiment, people were put inside the fMRI scanner and asked to do a task. Subjects saw stimuli like this, a series of pictures with some letters overlaid on top. They happened quite quickly. Each frame was updated every half of a second. Sometimes the letters repeated themselves in the next frame, like the word clock is repeated between the first and second frames here. Sometimes the identity of the object repeated itself too, even if it was tilted to a different side, like what is shown here on the second and third frames. Sometimes the letters formed a meaningful word, and sometimes they didn't. You'll see in a minute why this is important. There were two task conditions. In one condition, the subjects had to attend to a picture and press a button when the identity of the object was repeated. This meant that they could and should ignore the letters completely. And in the other condition, subjects were required to attend to the letters instead and press a button when they were repeated. This meant that they could and should ignore the pictures. Now, you might have already guessed what the point of the study was. The idea was, if we make people attend to one stream of information but not the other, how is the unattended stimuli processed in the brain? This is what the results looked like. Remember that language is left lateralized, and we talked about a frontal area called Broca's area, which is important for language. As you see from the plots on the left, this is what activity around this region looked like, when people were attending to the letters but not the pictures. Remember that sometimes the letters formed a word and sometimes they didn't. So the two curves showed these cases respectively. You'll see that when the letters form a word, the upper curve labeled as words with square symbols, the bold activity was higher than when the letters were meaningless strings. The other curve labeled as letters with triangle symbols. So far, so good. It only makes sense. Because this area is important for language. It may show more activity when one is seeing a meaningful, pronounceable word, rather than meaningless gibberish. When there was a word, there was more interesting processing happening, presumably. When reading a figure like this, let's pay attention to the axes and labels too. On the horizontal scale, we're shown time in seconds, so the activity lasted for around half a minute, which is the duration of a block of trials during which people performed one of the two tasks, attending to a picture or words. And you see that the activity at 0 was not so high, but it only peaked after a few seconds. That's because the bold signal is sluggish, as we discussed in class 1. The interesting thing is, look at the plots on the right. It's the same region, same way of showing the data, except that here it was the condition when people were attending to the pictures, ignoring the letters. Now you see that the difference in bold activity between meaningful words and letters were gone. That is, when one was not attending to the letters, it looks as if the meaning of the words weren't processed anymore. In fact, they also looked elsewhere in other brain areas that showed more activity for words over meaningless letter strings. In all of these areas where there was a sign that it cared about the meaningfulness of the letters, the difference was gone when attention was drawn away from the letters to the pictures. So that seems to count very much in favor of early selection. But hang on, not so quick. When we learn about a study, we should think about the limitations too. For a start, remember that fMRI has only limited resolution and sensitivity. Just because the difference between words and meaningless letter strings were gone when one was attending to something else does not mean the brain didn't process them differently. Maybe some neurons still fired more to words but weren't picked up by the fMRI. As we often say, no results are difficult to interpret. We don't know whether an effect is genuinely not there or that we failed to see it with our methods and setup. Another thing is, even if the meaning of the stimuli was not processed in this experiment, can we always generalize? Maybe it depends on the stimuli. Maybe it depends on the situation, like how difficult the task was. For example, back to the scenario when two people are talking to you at once. True that it is difficult to parse what one person is saying when you're attentively listening to the other, but what if somebody behind you screamed, "Fire! Help!" Or what if they said your name? Obviously, you're going to react. You're not going to treat those as meaningless sounds. So, looks like we're stuck again. Even if early selection works some of the times, at least at the level of what we can see in fMRI, it cannot always be true. Sometimes late selection seems to be true instead.